Okay, I suppose it's time to get started then, right? You have everything assembled?
Yep.
Okay. I will pass the presentation token to you.
Cool.
And everyone know it's starting.
Is there any kind of flag or something?
You may want to mute your monitor.
Hello. Okay, so I'm good to go now, and I'm going to start. I'm hoping that some people is there. Let's see. First thing first, we're gonna make sure I'm presenting my screen, entire screen. Share. Okay. Hopefully you are seeing the screen. Oh. Gerald, if you're kind of listening, can you turn off your sound?
Oh, that's not me. I've got mine muted.
Can we do something about that? Because it's not me either.
I believe it's coming from your computer.
Really?
Yes, that's it. I think there's.
Is that okay?
Yes, it sounds like it's cleared out.
Okay, cool. Okay, I'll pretend that none of that happened and I say hello to the people that are here. There's someone, and I'm not myself. We're gonna talk about F-sharp and games. There's some more stuff there. Whoever's doing this with us today should get this. If you're in the video right now, you should be able an example code to see the thing and download it and make sure it works. If you're there, can you chat and say that you got it? At least some people, so I know more or less if you have it or not. Because it's really weird to do this without feedback. Yeah. So meanwhile you're doing that, remember, go there, download the code. I'm gonna assume that you have gone there and that you're starting to download the code. When you do download it, kind of give me some sort of live signal so that I can show you what to do. Meanwhile, I'm going to tell you a few things about games in general and games in F# in particular. The first thing is if you like games, the best way to learn about games is to go to game jams. There is one in London on the 29th of November at Skills Matters, and in December and Paris and Vienna and London and New York. And there's all types of game jams, so you can always make games. And if you don't know where to go, just give me a tweet, and I can help you on finding a game jam to go to, because games are fun, right? So this particular brand of game jam called GameCraft is something that I organize with our people. And if you don't know what a game jam is, it's basically kind of like a hackathon, but the idea is that you make a game. So generally our ones last about 12 hours, but there's the game jams of any durations. And that's kind of nice because you have to finish the game in that time. So anyway, since we're doing this game-related stuff, it's really important to understand certain basic stuff about games in particular. And one of the main things that games have is a game loop. And a game loop is basically what you see on the screen. That's some pseudocode. The idea is that you do some you can process some input because you're playing, so maybe you're going left or right, or you're using your controller to jump or whatever it is. Then you update your game, like any logic such as physics, AI, anything like that, and then you render. And this happens on a 60 frames on a 60 FPS. This happens every 16 milliseconds. So this is the main difference when you compare something like a game to something like a website or anything like that. And in a game, something is happening definitely all the time, where in a website or anything kind of like our line of business applications, we're waiting for the user to do something for us to react. And so when you're writing code for this, you just remember that you're doing this. Anything you write that is on update loop, it will update every 16 milliseconds or more. So that's an important thing to keep in mind. Another thing we're going to see today is scenes, components, and game objects. So I'd like to be able to draw on this. I'm going to do this thing stuff. So let's say we have a scene. This is my beautiful drawing. I know that it's so this would be a scene. I think this is like an abstraction of it, right? In each scene, you have game objects, generally quite a few of them. Game objects are very dumb, and generally they're just a container for other things. I'm going to draw this in very bright color. And we're going to say that each one of these game objects have components. And the red circles would be the components. And these components is actually where the logic lives, the logic for pretty much anything. There's different types of game engines that have certain differences about exactly where the logic lives. Some of them have logic in components and scripts, depending on where they consider it should go. In the case of Duality, which is the game engine we're using today, it's all about we're putting everything in components. Even when we have scripting, we're basically kind of descending from a component. So this logical diagram is about the big thing that has everything is the scene. And inside these little square boxes, or somewhat square boxes, are game objects. And inside we have the components. And I'm going to show you now a real, this is Duality. It's an open source game engine, and it's quite nice. It's very, if you're familiar with Unity 2D, sorry, with Unity 3D, this is like a 2D version. So we go to GitHub. That's me. And I'm sure I'm going to Breakout. If you're gonna, you're probably downloading this. I'm gonna accept the. I'm sorry. Assume that you're actually downloading this and everything. I wrote down most of the stuff I'm saying in the README for this. There's also some helpful links, for example, to the Duality website, which explain there's a nice workflow and explains how the architecture works. There's a tutorial, and just so if in case you want to come back. So I was telling you about scenes and game objects and components. So when you open this, you downloaded everything and you unzipped it or just cloned it, you probably got something like this. If you immediately go and run dualityeditor.exe, you would have seen something like this, which is nice. And I'm going to pin this so we can see errors or anything strange happening. And if you double click on scene, you should have this like this or like this, like maybe far away or closer. Maybe you saw something like this. Too close. So perhaps you saw this side. If you change that to game view, you would see the game. Which is nice. So this is a very, very important part for you to follow along. The idea of this whole workshop is that you are following along. If you're just watching this, you'll probably get really bored. So I really need confirmation that you all are here at this point where you can run the editor. And I don't know how to get that confirmation. Other than nodding or I have the code. Cool. Mark Brown has the code. Woo! Yay! And I wonder if anybody else has the code. Anybody else, please? Okay. Well, I am gonna assume that everybody has the code because otherwise it's gonna be really awkward. And so I'm gonna kind of keep going with the description of this. So this is a scene. And the important thing about a scene is that it contains all the game objects and components. I'm going to show you how this is represented. Basically, it is just an XML when it's serialized. And that is good. I'm hoping that you can see this, but basically, let's see if I can see if someone's saying something on the internet. Attempting to join or puts me in a call with all people for some reason. Okay. Okay, sorry. I was saying that you get your serialized stuff. So I'm going to give you an example. So in here in score meter, we have a component called score component F. We go search for that. Score component F. See the way that it's saying, hey, I have this component here. So a scene contains game objects that contain components. Objects. So that's good. This being a game object, these yellow boxes, and these being components. Text renderer and transform and a few other ones are provided by the engine, and they give kind of common functionality. In this case, the text renderer will render text, and if we do this, see the way it focuses on score, and it helps you render the text. A transform is what gives you the ability to position stuff in the world. In this case, we have scale and angle. It's a little bit self-explanatory. If you don't understand, you can please ask questions, because it's hard to know what people get and what not. The important thing to remember is a scene contains a bunch of game objects. A game object is basically an abstraction that does very little except contain components. And components is where the whole logic is. So with that, right, we're going to go and do the first exercise. So if you go to, we're going to go to where you unzipped your code, and we go to source, code, and open the project solution. Sorry, the project plugins solution. Then you would probably see this. And the idea of, sorry. So what you see here is this 4 projects. The first one is where you are going to work. The second one is where the solution is, in case you get lost or get curious about how stuff can happen. The third one is the original C# game. So before I started, I did this in C# I don't really know why, I just thought it was a good way to start. And so the game was there with all the classes. It might be very helpful if you come from C# and find F# a little bit alien still, because what I've done is basically ported and trying to make it more F#ish as I've gone forward. So the way this works is that there is all this to-dos. So if you search for something like this, you will find 5 exercises that you need to complete, right? So we have 0, then we have 1, and so on and so forth. 2. So what I'm going to do is to start with 0 and take it from there. And if you have questions, please post them up on YouTube. And Gerald, can you let me know if people ask questions, perhaps?
Most certainly.
Cool. Also, if I'm boring you to that or something, I really need to know. Because I don't. It's really hard without feedback. So I'm gonna just assume you're following along and everybody's having fun. You're laughing. Like that. You can do a fake laugh if you want to. It's okay. So I'll start with 0. So we're here in components, okay, and we're looking at this component called brick. Okay, so this is a type brick that inherits from component, where component is actually a class that exists in Duality. So I'm gonna go here just to show you component. So in Duality, you can kind of deserialize this. Sorry, not deserialize, decompile this, and just have a look at what it does. If you're curious, I don't know, like certain people need to know, certain people don't need to know, I don't know. But it's just a class that has a bunch of functionality that is common to components. So that's good if you want to have a look. So to implement, to make stuff happen in this component, sorry, we were in brick. Well, our first exercise is to do. What is the line above doing? Why do you need it? So the line above is this.gameObject.dispose later. But let's investigate what is happening here, right? I mean before. So I'm saying that we're in this component, we're implementing the interface ICMP collision listener. Probably something to do with collisions. Cool. So when the collision begins, so I'll come back here to the game. This is a brick. Okay. So we're saying score component, increase score if it's not null. Okay. That's kind of cool. So let's have a see. Look. We're here. Bricks. Okay. So if we go to any one of those given bricks, we have this brick component, and we can see there's a brick component here. You can do this thing where you put this in debug mode, and if you have any exposed properties, it will show you a bunch of stuff. I hope I find one. Okay, that might come in handy at some other point, but basically this means it's auto-refreshing on sandbox. But the one we're interested in is this brick. It doesn't do much, but we know that implements it will do something on collision with something. And in reality, because this is Breakout, the thing that will collide with us is the board. Let's play the game. So, okay. So what I do see is that, and I'm going to die very soon, when I collide with a brick, my score increases. So let's try that once again with feeling. 4, yay! Oh, and I died. Oh no. So that's good. So in here we want to see that we know that when I collide, I increase the score, which is something we've seen happening, and the brick disappear. Maybe this is something to do with that. But just to make sure, we're going to comment that out. Build. This thing will disappear right now and appear again. And here it is. And we're going to open it up. And now I'm hoping that you're guessing what is going to happen. I mean, if you were here with me, I would pressure you into telling me what you think will happen, but you're not here. So I'm gonna just do it. And the score did go up, but the brick didn't disappear. And now I have 3 scores. So now we know that what this line of code was doing was disposing of the game object. So now we figured it out. Okay? If you don't dispose of the thing, then they will not be there. And the reason why I ask you to do this, which is kind of simple, is so that people get used to working with the editor and working with some F# code and kind of getting familiar with the solution. So I hope you've done that. And if not, ask questions so that I can keep going. Yay! So I'm going to move on to number 1. Number 1. See, all of this is really easy to do if you're not doing it yourself. Or maybe I'm just crazy, but that's what I found. So anyway, now we found the to-do number 1, and I'm gonna go check if any questions or anything. Cool, just watching. Cool. So number 1 tells me improve on this. Don't use an if, as we don't really need it here. In pair matching might help. Another hint, maybe options can help as well. Another hint, you might have even a better idea. Let us hear about it. So here I kind of really use this to find out about the knowledge of F# in the class, really. But again, we're online. This is a different world. So we're here in score component F, and we have a private field, a public field, a function for increasing score that actually we just used on the previous episode, like let's say when we did that exercise 0, that basically increases the score by whatever amount I set. However, and that's all well and good. And the interesting part here, or regarding our exercise, is to try to make this into not an if. And when I was running this in our parts, we got into the discussion of was that really necessary or not, and because it's not really terrible code. I mean, you could do something about assigning this and reusing it so that you don't have to go search for it twice, but it wouldn't be really the end of the world. And I disagree with that, but this is about trying to learn F sharp and games, and it seems like a good plan to try to show the stuff that is possible. So now you know that the if and a very kind of you basically I copied this from C# and changed a few things, and this all kind of worked. Uh, but maybe you want to do something else. So anything else? Okay, common questions that I get here is okay. This is a score component F. It's serializable because, as you saw in the scene, it is serialized afterwards. This implements ICMP updatable, which is an interface. The method we're implementing is onUpdate. And if we just go and look at score component, we'll see in score meter this score component F. There it is. And if we look at the namespace, it's going to be Breakout F#. If you remember when we were looking at the XML in the scene, go look at it again. Let's just go back. We'll go F. So there it is. It's in Breakout F#. Breakout F# score component F. So there it is. It's more to try to get you used to thinking about what is happening in the back, not just what is this code. So this should have given you some time to kind of think about how to make this if disappear, which is what we're trying to do. One way we could do this, and this is a common way, is match with, probably get rid of this parentheses. So that's really cool. And we say, this is null. Let's get rid of this. This is null, don't do anything. Or maybe you want to log this, I don't know. And if it's not null, we could call it expander or PR. We give it we assign it a name. We give it a name. We can get rid of all of these, which is nice. And this is slightly shorter. And that's pretty cool. And that should work, right? That's nice, right? So we could do this. And there's another way to do. There's actually a good few ways to do this. If you were trying to do it yourself, which I hope you were, you probably scroll down and you saw that you're already doing this in the live meter just a few lines below. And that's kind of cool. I mean, that's a nice, maybe maybe not totally necessary, but good use, a good case to show power matching. Another thing you could do, right? I actually think I have this. Is you could use this option component. So I'm showing this from the solution just so I don't have to type it, and I'm cheating a little bit. But I created this little option component thing where if I pass it a component and it's not a struct, it's a component and it's not null, then I return none for null and some line for line. So I'm using options. And in this case, I've done this, which can be, again, kind of nice. These are just ways to do this. It doesn't mean, none of them are like terribly wrong. So this is about trying to show the first iteration when I ported it from C#, second iteration which is pattern matching, and the third one. And this is just options. So that would be number one done. If there's any questions, let me know. Otherwise, I'll be moving on to 2. Right? So in number 2, it tells us about the position of this ball is not really where it should be at the start of playing the game. It should be in the middle of the bat. The ball should be right on top of the bat. At least people with OCD. So, okay, at the start of the game, is this case, right? So obviously, if we, I'm going to put this in scene editor so we can see better. So see the ball there? That's just crazy, right? So what we want is the ball more or less there. And yes, maybe we could just drop it where it should be, but that wouldn't be fun enough. It has to be precisely where it should, right? So actually, I haven't done this in a while, so this should be fun. I'm gonna resolve it like I think people resolve it. So the way that works is the following. We are in this bat component, and now we're used to this, right? We are inheriting from component. I have this really two helpful methods or functions called half width, half height, which take a rigid body, and that's good to know. Meanwhile, we have an implementation of ICMP updatable, and we're thinking this is something about going left and right, and that's all well and good, but we're concerned about the position of the ball, which is happening here. In here, we're finding the ball in the scene, and we're setting the position by finding the transform and position. So this is here the transform. So this is this. We want to modify this initial position when we're doing F5 basically in the game. So let's do that. So when I was doing this initially, I was like, hey, let's make this wrong on purpose. So I added 100 and removed 50 from here. So I'm modifying X and Y, X being a horizontal movement and Y vertical. And so maybe the first thing I should do, right, is take this out and see what happens. So we're going to go to the building of things, everything built, quality disappear. I'm going to just close this and wait. So that's good. We go to scene, put it on game view, press F5, and now where would the ball be? I removed minus 50 from the Y, and this was starting somewhere here. So I think it might be in the same position on X, but it probably is a little bit better on Y. Oh God. That is terrible, isn't it? So we should go and fix this. But now we know that if we remove on Y, then that's good. Well, actually, it's not so good, but now we know that we're bang on in the center of the bat. So let's see. If we add on Y, then that will probably work. But I wonder how much on Y should we add? Should we add perhaps half of the height of the ball? Maybe we should check. Okay, let's go check. As we've seen, we have a half height function here. Yeah. So if I posit a rigid body, that would be kind of cool. So we know that we need to add, or maybe remove. Let's see. Half height of the ball. And I'm going to do this just in case I put something else one. Let's say let all equals this. So I can refer to it, and I'm going to pass the rigid body. So we're going to say ball body. So let's see what happens. Maybe we should remove it. This is where the script will be a little bit faster. Okay, so let's find this. Oh, it's below. Okay, so now we need to do this. Let's do this again. So we play. That's better. Okay, so maybe now, if we zoom in on this, scene enter, let's ball. See, that looks like we're well on Y when it comes to the ball, but we have half of the bat, so maybe we should add that too. So we know what we're doing now. We need the bat as well. Where's the bat? Oh, the bat is this. This is the bat, because we're in the bat. So we could say this, maybe do this, and say plus half height, no hash, of this game object. And if you're wondering why this game object is because we are on the bat and we want to know the height of the bat. So let's compile this, go away, and come back. Cool. And if we play this, let's go to the ball. That's better, isn't it? Cool. Now we need to fix X. So we fixed Y. What about this? We get rid of this. See what happens. Remove X. Let's see. This is the first iteration cycles we're looking for. I don't know you, but I'm pretty happy with that. Now, there were some purist people that wanted the ball to be in here. You can also do that. You could use that half width function that you have and move the ball on X towards the left a little bit more. But now you know how to do it, right? Because we've changed the vector into, moving to the correct place, right? I'm imagining all of you nodding in agreement. Hopefully you are. So now that we've done this one, we should do this thing saying to do, find the ball once above. And this is very simple exercise that confused a lot of people. I think it's mostly because how I explained it, but also because it's very natural to confuse components and game objects when we're starting to think about them. So it's actually very simple, but confusing. So in here, I'm finding the game object ball, and in here, which is a scene current find component ball, in here we're finding the component ball. So the difference is that with the first line, find game object, we're finding this and all of the, like you can have access to all of its components. And in this one, this other one, the find component, you're finding this particular component. Now, the trick is that when you do this, I'll actually give it a name. When we do this, that, I'm call it all, and people will give out to me, that's okay. When I find this, it's a component. But if I do this, and I do game object, I can easily gain access to anything to do with the game object, which is very handy because here I need the game object, right? So what I could do, and the point of this exercise, the number 3, is to do this, which is have unused the component. And in here, instead of do ball define game object, we can just use the ball that we just defined that one, do it all game object, and gain access to all the properties of that. And I would really love to know if this makes any sense to all of you or any of you. So if you can comment, that would be great. Um, but meanwhile, I have to kind of keep going because I don't know what's happening. Um, so so far here, what we've done is then learn a little bit more about game development-ish in that we use this vector stuff. So we create a new vector to modify a current vector. That was before. And on this one, on number 3, we just learned to kind of deal with components and game objects, which is very, very handy. Because in these types of engine, a component-based engine, you will be doing this all the time. So it's good to understand what's going on. So with that in mind, we're going to move to number 4, which is thankfully above us here. And what I'd like to do is I'm going to explain the problem and then actually do a pause of like 2-3 minutes to see if anybody wants to say anything, because I'm not sure. It's really hard to know what's going on without feedback. But meanwhile, I'll explain number 4. Number 4 says use active patterns to improve on this code related to pressing the keys. So the problem is about trying to replace this logic, the duality keyboard press, key right, and key left. And all this code will do, this R code will do is basically control that you don't go over the walls. So this one will make sure that you don't go over this wall, and the other side of the code will make sure you don't go over this wall, so that the bat will stop around here. It doesn't, I'm not sure it does it as well as I'd like to, because you can see a little bit of overlap in that side, and we'll have to fix that. But you can do it as an exercise if you want. So in here, you can do the following. I'm asking, by the way, one common question I also get here is, why are you trying to use active pattern for something kind of so simple? And the reason is that active patterns is, first, it could be that it gets more complicated. It could be that you're pressing left, but also you're not pressing right. And also you're holding control because you're using a power up, or you're not. So you have to control that you're not have that power. So all of this could become more and more complex, and that's kind of common in a game. But also a good point, I think, after showing this a good few times to a few different people, is that finding good examples that are non-trivial of active patterns can be not very easy. But when you need them, you need to understand when they, how they turn out. In this case, key pressed. So if you look at keyboard is a keyboard input. So the type of keyboard is keyboard input. And when you press a key, it returns a bool. So in here, ideally you could pattern match. If you said key press and you could just get a key and it returned the key, that would be super useful. But this is not the case, because of what I said. You could be holding multiple keys at the same time, and then you probably hit all the conditions. But the good thing about this one is that or bad if you want, is that it returns a bool. So are you pressing this? Yes and no. So what can you do? And because I don't like typing so much, I'm gonna pause and ask, are you guys there? Are we happy with everything? Do you have any questions? Anybody?
Currently don't see any questions coming up in the chat.
Okay.
I'm going to assume so far that everybody's following along quite well.
Cool. How about you? Do you think like the rhythm is good, bad, okay, more or less?
Well, I'm following along quite easily. I've worked on the component and game object. I can see how that would be easily confused. However, when you look through the scene view itself, it sort of makes sense. After kind of exploring around the editor environment.
Cool. Okay. Awesome. Well, if everybody's okay, and I'm gonna wait for the time. I'll just keep wait. Just wanted to check and give, enough room to people to kind of say, actually, this thing doesn't make sense, and that we're totally fine. But I'll keep going. Thanks, and thanks, Charlotte.
Sure.
Okay. So we're gonna try to fix this, right? And what I'm gonna do is moving objects. We're moving objects. I'm gonna go and skip the typing so that you don't have to wait for it. But if I was typing, I would go and write this active pattern. This is a multi-case active pattern that takes a parameter of the keyboard input. If you remember on our original situation, the keyword is here, and that's what you're passing. And the things like this is static, so in reality, you probably don't need to pass it. But I think this makes it more constrained and better. It is. I've seen very smart people not do that, and I've seen very smart people do that. So, I'm gonna follow my instinct and just do something. So in here we define left key, right key, and other key, and we're saying that if we press the left, we're gonna say that matches left, and if we press right, we're gonna match right. Alternatively, I'm just passing, just returning with a string, saying OR key, just to show that actually when you're passing this left key and right key and OR key, you're actually returning with a unit as well. So in here, you could do something like that. Wait, that's actually this could be confusing. Just forget that. So when you do this, the good thing about separating this is that you can separate the logic about what is that you're doing from an input point of view from what you're actually doing. So here, I find that quite easy to read. So you're saying you're matching on the keyboard. If it's left, you do this. If it's right, you do this. Alternatively, you do nothing. And here I have access to the string. So if I wanted to do something like this, then that'll be fine. And that's kind of what maybe you want to do now. So this is kind of handy. You could also that's one way to do active patterns in this case. This is a multi-case active pattern, but you could also maybe not do that. You could have a per case, a single case active pattern in case you wanted to do something fancy. And this is where I have this OR example, and this is where in games you could have this slightly more complex cases, in that, for example, you want to have is left something, and so, sorry, you're pressing left, but you're not pressing right, and also you're holding the controller button for some sort of length of time, and that's very, very nice, because that is a common, well, a common scenario, I'd say. And it's also another way to do this, which could be handy in some scenarios you're in. So this is some options on how to do active patterns. And yes, that'll be how I would solve this. If you want to read up more on active patterns, I recommend you check some of these. There's actually another link I should add. Luke, this guy Luktopia, he also did a presentation on active patterns that are on slides. That I will add a link to that. These three links. This one is typical Scott Russian in that it's super nicely explained without any complex language. I love that blog. If you like F sharp, that's F sharp for non-profit. Definitely check it out. Richard Dalton, who is actually part of the Irish game community, Irish F sharp community, and functional cats, he wrote a series of posts about active patterns. And if you want an in-depth review, that's a great series. And this one is too pretty good. That actually, help me get them at the first time. So make sure to check this out in case you're wondering where this active parent stuff came from. So with that, we just finished exercise 1, which is super good. Sorry, 4. So we're gonna do number 5. Okay. So in here it says add some logic to add a win condition. Bonus point. How do you get bonus points? So in here, what do we have? Let's see. We have a win-lose condition component. Okay. And on update, oh, at the moment, this is what makes the game over happen. So let's go and check out what is all of this and where is it, because it might help us understand the problem a little bit better. Also, if you remember, the bat disappears when you game over. So, we're saying this win-lose condition. Okay, you know, this tool has a very nice filter here, so that is telling us that we have a win-lose condition there. So if you're typing here, you find it that way. So we know that we have one there. Then we had a game over object. This is when you do this, you're searching by name. So the way scene, find game, object, name, and active only. So we're gonna go and search for this game over object. Oh, there it is. That's nice. So where is this game over? Oh, we're gonna put this on scene editor so we can see it. So there it is. There somewhere. Cool. We could activate it. See the way this is not active so that we can see where it is. Cool. Okay, that's nice. So we know that we have a win-lose condition in application. We have a game over object that has a text renderer. Perhaps what we should do is that if we have no more lives, then we should, sorry, if we have no more bricks, then we should win, right? Because that's how it works, right? So let's have a look. We have bricks. Cool. And these are active. So perhaps if we find all the bricks, that would be good. I'm going to be typing really slow so that you can also be typing and perhaps come up with a better condition. Okay? So I'm going to go see. How do we find all the game objects called brick? Find game objects. Of T. I would really wish I had some holding music. I'm hoping one of you will beat me. If that's so. And is that what's gonna happen? So bricks.
Now, am I correct in assuming that find game objects of type brick is going to return a list?
Yes, I would think so. And actually, I kind of wanted to find out by debugging, because I assume that's what people would do if they were trying to do this. So let's see. Can we actually debug this brick? That brick is not found. Let's see. Oh, maybe we can. Oh, because brick is in non-moving object. Maybe we can find it by name. Oops. Also, I think there is a better way still. Actually, what we can do to find out in a more like signature way, this should, yeah, it should give us back an enumerable of game object. So this should say let Mm, okay, private each one. We'll do this. Actually, that's probably a sequence already. So we could check. With the map. You know that this is a game object. I wonder. Oh, this is an interesting thing. If we go here just to find something else, let's see, and we do this. Hmm. Okay, what I'm trying to do is the following. I might be very, very misleading and confusing in what I'm doing right now. But basically, I was thinking, find game object. See the way here, it asks you if you want to get the game objects that are, are active or not. So I was thinking that perhaps find game objects. If I didn't have a true here, like this, then it would return only the ones that are active, and if that collection was empty, then I could say, well, I've got none. But I'm not terribly sure that is the case. So I think there's only one way to find out. And that is, well, probably a bunch of ways to find out. But what I'm going to do is rebuild. Um, this is giving out to me saying I don't have to. Okay, so we'll do this. Wait for the thing. I actually have a different solution, but I'm kind of playing along to see if someone else is say, "Hey, I have a solution for you that is better than the stuff you're writing." So to encourage participation and stuff like that. And so let's see. Did I just restart? Oh, the other thing is we probably need to make our win condition slightly easier. So I'm gonna make the ball very big. So I'm gonna say scale, I don't know, 3, so that it's like easier to hit things. Let's see if that makes our life easier. Oops, sorry.
Well, we're guaranteed to win now.
What?
We're guaranteed to win.
Wow, I'm really bad at this game. I'm gonna also make the ball slightly even bigger, maybe 5. That's like really cheating. I saw someone else doing something like uh, um, just making the win condition. You need to remove 3. Oh, you can do it. Or making the bat super big so you can't miss. Yeah, I'm gonna do something even more easy. Come on, do it. I know only one life left. Ah, no!
Oh
uh, oh, okay. There is how many bricks? There are. Okay, and also I'm not actually doing this. Okay, I'm gonna pull people out of the misery of watching me type. Um. Oh, well, wait. We could debug this. I kind of thought this would. Yes, I know neural count. Maybe we need this. Do I just want to see. Also, we could debug and just find out. I'll debug just for the crowd, but again, waiting for people to come up with something better. But otherwise, I'll show you a solution I worked out earlier. This shouldn't be okay. That won't be possible. Hmm. Oh, this didn't restart. Hello. We'll build solution, and we're gonna go here. Uh, whoop. Okay, so we open the scene. The scene is there. We have a gigantic ball, and when we play, okay, let's see, bricks, count, looks view. Okay, so we have plenty of things, and if we do bricks count, what do I get? Oh, that's interesting. I guess someone is watching this going like, no, but you're doing this crazy thing, and you shouldn't. But because I'm writing, I'm not thinking. It's, I have a link. Oh, I think I didn't include link on this. Okay, fair enough. Leave it that.
I believe you may have typed LinkedIn wrong.
Sorry?
I believe you might have typed in length wrong.
Oh, yeah. It is quite possible. I'm really good at messing up when I'm talking to people, and also when I'm not talking to people. PH? Nope. I'm gonna try HT. Nope. No, it doesn't like that. I think there's. I don't know if this kind of actually can do what I'm asking it, but that's okay. Next out. Oh, we could say it's empty. Oh, okay. I have an idea. We could do this. It's empty. And it's the same. Let's giving out an object. Oh, okay. Oh, we can do this. If, oh, let's say dimensions. So what I'm doing here is trying to get this and get the text renderer finding object. Until we can do this. Nothing else. Sorry. Oh. Yeah, that doesn't sound right. This is very strange. Okay, I'm gonna go check this components. Oh, okay, I've actually done the same thing. That is weird. Oh, this. Okay, so great, I arrived to my same conclusion. Components, and we can do this. Cool. So in here, what I'm doing is, I guess, slightly different to what I've done before, but it doesn't matter. So what I'm checking for is if there's no bricks, find the game object game over because we have a game object there. Find the text renderer, and okay, we got bricks in the end. And once once we have that, just change the text so that it's something else that makes sense. So we should probably go and check that this works. And this should restart. Yes, it is. Turn this off. And we have that scene there. And maybe we can make the path also bigger to win quickly. Paths. I can make it too. Oh, this is easier. Oh, cool. Even that way I lose. Oh no. This is all really to give you time. I mean, totally. Oh no. Do you think we would win? Oh, I should have been pressing this brick. No!
You're gonna get it.
No, no!
Oh.
Oh, you won in the end. Okay, it worked, but it shouldn't have worked. It's one or the other. You can win and lose, or lose and win. Um, okay, so we need to check that we haven't lost before. I guess we do an else. And move this. And that should be better. And that's, well, that's kind of the core of the workshop, which is actually generally slower because people are doing it, not me, and I kind of know more or less the solutions as I shown, so it's like less exciting where you don't have to work it out. But what you should do, I mean, if you were following along, is you can implement your own kind of some sort of power up. So one thing that that I've done is like double points. So you hit a special brick, and what I'll do is stop this and come back to here, and just restart it for this case, and go to Breakout editor. So you kind of go to one of the bricks, like obviously this one is kind of selected for you already. Scene editor, choose that brick, and this one has double points. So what happened there obviously is that make it do double points. But always I was asking like stuff like, hey, okay, you go and implement your own crazy score, and some people did stuff such as making the bat change size after you hit something. Some people might change the wall. Some people make the bricks, instead of kind of disappearing, to fall slowly, and it's kind of a lot of fun. And because you kind of hopefully after this have the capability to do stuff. Um, so I don't know. That's kind of it for me. Um, I don't know if this format works in this medium. I feel that we miss something because of complete lack of interaction. But if you have questions, this is a good time. Um, and yeah, that's kind of it for me.
So it looks like you're kind of mixing the object-oriented design with this a few functional lines of code. Is that pretty much how you've got it laid out with this?
Well, yeah, the main reason that you the engine we're using, it kind of makes you do a lot of stuff in a kind of very opinionated way, and you have not a, I don't have a lot of choice except inside the components. So for example here, I can't do anything about the rigid body, or for no, no, no. I can't do much about what I can put as a parameter for a vector, or the fact that rigid body is mutable, or a lot of stuff like that. So what you're trying to do is just bring the goodness of a functional approach wherever you can, rather than trying to make it an all or nothing.
Sure. Yeah, that's understandable.
Yeah. So it's hard to bring it into an existing engine. I think if there was an engine that is fully functional, I would be very curious to try it out. I was talking to a bunch of people who are trying to implement it or have implemented game engines that are fully functional or functional and reactive. But the main problem is that you actually have a memory limit because of how many objects you actually need on a game of any significant size. You can do stuff like on Breakout or even slightly bigger, but you run into a problem where you have to recreate your complete state every 16 milliseconds. Then some people kind of take a middle of the road approach where they recreate some of them. I think there's a lot to research there. But meanwhile, we do what we can, and it's possible to do cool things. This example is that what we've seen today is more about trying to slowly introduce it, and trying to learn F# in a fun and not pressured way. I think and it's not about trying to introduce purity, but just slowly walking F# code with a game. That's it.
Okay, I guess it's a good thing I popped in here for that statement. Hi, my name's Brian. I'm an F# programmer. I built a pure functional game engine. Um, could you elaborate a little bit more on what you mean when you say you have to recreate the entire state?
Sure. I mean, when you're
And the
if you
cost that you see from that?
sorry, I lost you there. I lost a little bit of your question.
Okay, sorry. Let me state it again. Could you elaborate on what you mean by when you say you have a pure functional style? What do you mean when you say you have to recreate the entire state?
Oh, sure, sure.
Can you can
So
you can you tell me what you perceive to be the performance implications of that?
Sure, no problem. So in this case here, right, I'll go with this example because we have it. In this case, I can keep and mutate the state of pretty much anything here. And then this is just a small, tiny game. So destroying and rehydrating or recreating all of that is no big deal if we needed to do it. Um, I would think that in a completely pure version of that, and this is my guess, right? Now I haven't gone and created one of these. You would have to kind of bring them back to life from previous versions on anything that changed at least. And if you have a game with, I don't know, 6,000 objects or more, and they have to, in top of kind of having to change whatever you have. When I say change, I mean something like a samurai or the ball moved from X10 to X25, and in the middle you have to check, did you collide with something on the way or not, and stuff like that.
Hey, bro,
Hmm?
can
So,
I get some fries with that shake?
uh, I don't know what he said. I'm sorry.
You
But basically
Can
the
I
thing.
get
trolls.
can I get some fries with that shake?
Yes,
I'm rolling at coins.
have my fries.
I think someone is very funny. Anyway, sorry, Brian. I think to try to keep that short, I think it's about that anything, for everything that you change, every game object or component inside the game object that you change, you will have to create a new instance of that, and the performance cost of doing that would be quite high for a significant game
That
size.
would Okay. So that would definitely be true if you didn't have what's called persistent data structures. Um, so, for example, and actually you probably already covered this, but say you have, for example, an F sharp list. Um, and if we want to make three new versions of that same list, uh, because it list is a persistent data structure, we don't actually create three new lists from scratch. What we do is we find the smallest delta, which would just be a change in the pointer at the I think the beginning of the list. Or no, we change a pointer to the new head we put onto a list. Say if that was our change, was adding a head to a new head to this list in three different ways. That would just be a matter of basically constructing a single, say like one one. We have to create one new cell, which is probably like 32, maybe like maybe 4 bytes, and we construct that. So we could have a list of say a thousand nodes on it, but if we want to change it, we don't create a new thousand nodes. We create a new cell which points to that existing list. So it's just a matter, instead of creating like like 4 times 1,000 uh, bytes,
Yeah,
we just a matter of like it's just the operation of like uh, it's like a 4 byte operation. And so list is a persistent data structure. So that kind of gives you a simple example. More difficult examples is something like a binary tree, right? With a binary tree, if we want to add something to a binary tree, we don't recreate the entire binary tree because it's a persistent data structure. What we do is we find the spine that goes from the root of the binary tree down to what we want to change, and then we recreate that spine. And so if we have a binary tree that say that's 4K, the spine's probably only going to be like maybe 32K. So again, it's a matter of it's more like a log in memory operation for a binary tree than it is like an in operation over the binary tree. And fortunately, this logic also recurs for when we want to do an entire game state data structure. For example, in my game engine, the entire world state is a persistent data structure, which actually naturally falls out of using the discriminated unions and product types of F sharp. Um, so if my world is say a megabyte, and my world contains a game, contains a screen, contains a group, contains an entity, and I want to change the field on the entity from visible to not visible, I don't have to recreate the entire world. I have to change that. I have to create a new entity with a with a different um, with a different different visible field on it, which in itself is actually a login memory space, because itself is a persistent data structure. And
And then how do you, sorry to, I kind of, how do you say, for example, you have an example such as this one on the breakout stuff, right? In this case, how do you find a particular game object or component, or I don't know if you have game objects or components, but let's,
oh yeah.
something similar to that. How do you find something so that you can change the state of the world?
So there's a couple of different ways. If you in the editor, when you're putting together scenes, you can optionally give each entity a name, and then that name is basically it uses what's called an address, and then what it will do is it will search through. So okay, the screen has a name, the screen's group has a name, the screen's group's entities can optionally have names. So if you want to find a particular entity that you've named as such in an editor, you would just give a little query to the world, and the world would find that by traversing through this binary. I'm sorry, through this. It's an F sharp map, which is a binary tree that.
Oh, yeah, that's super cool. That sounds great. Do you think you want to do another presentation? Because this was like F sharp in games, like we can do it, and there's some way to do it. But I
Yeah,
actually,
I don't want to derail you, but I want to make
no, I
very
think
sure
we're quite interested.
that we take into account the performance advantages of using persistent data structures, as opposed to like if we were just to do the naive thing and just copy everything. That definitely would not work. But that's not really idiomatic in F sharp.
Cool. Well, I don't know other people, but I'd love to see it. And I think it would be very useful, even if the people aren't doing games, as a way to understand better those type of data structures. Unless, I want to hear it. So I don't know. I hope other people too.
Yeah, at some point I'm supposed to. I should do something, but we'll see. We'll see if we can. If Gerald can me and Gerald can put something together.
Yeah, I hope so. Because I've been hearing about your engine, and I did have a look, like a light look. I have that. I've been a little bit short on time, but it's very interesting. Another approach that we were talking about with Anthony Bruin. I don't know if you met him. He's doing also F sharp games. Is trying to do
Yeah.
something on top of monogame and trying to use event sourcing. And that is really interesting because kind of trying to use events and commands as a way to drive the world, and this basically makes the game engine totally replayable, and that sounds really cool as well.
Yeah, event sourcing. That's definitely an option in my what I've done. I don't know, like that would be relatively straightforward to implement. I don't. I guess I haven't really seen the value of being able to replay that just yet. But that's sort of like that goes again with the great thing about persistent data structures is that that type of it makes that type of thing possible. Do you know what his
Cool.
motivation was to implement the event sourcing?
Sorry, repeat the last bit I heard.
Yeah. Do you know what his motivation was for implementing event sourcing?
Um, I don't remember off the top of my head, but I was talking about this with someone else, Jeremy Chassing, because he was talking about event sourcing, and he was suggesting that it would be a great way to have more interaction, like live interaction with the code, uh, and other reasons. I was kind of interested in that because we do want a replay system ourselves, and we found that it was really hard to implement with a non-deterministic game engine. And I was like, listen, this probably is not possible because you need a high level of synchronization in a game. And he was like, no, totally possible because blah and blah and blah. And so it piqued my interest enough to kind of think that we should talk about it. Anybody that is doing games and in a functional language, which is sadly not a lot of us. So it's just a question of exploring these ideas and how they're possible, what benefits they bring. At the moment, for me, it's like, hey, I wonder if anybody did this and if it's possible, and if so, then how do we do it and what are the benefits?
I can see two issues that could be possibly insurmountable if you're using, say, like an existing engine that's either OO or imperative or whatever. The first problem would be, uh, you know, are they using a deterministic random number generator? Um, and in gaming, you're supposed to, but that way you can get like replays and stuff if you want to do like a demo or whatever. But probably a lot of existing engines don't use deterministic random number generation.
Yeah, no, they generally don't.
It's system random, and that's not going to be good at all.
Yeah,
And the other problem will be like without persistent data structures, um, it becomes very difficult to figure out a clean way to persist changes over time. With persistent data structure, all you have to do is just take a pointer to the well, this is just one way to do it. Is to take a pointer to the data structure as it is over time, say like once per per interaction, once per event interaction, and then you can just replay that. Um, so 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 I'd say that that's definitely an advantage that functional programming would offer, and I am interested in seeing his take on it, whether or not that's whether or not that type of thing is generally useful enough that it should go into an engine um, without a specific use case.
no, I think I think the replayability is something I was interested in, but I think that the event sourcing as an approach could be beneficial because in certain games in particular, because you have this kind of ability to replay is good for debugging, and debugging in games is hard by inherently. If you could have more replayability, you could do something like, I don't know if you've seen that presentation by that guy that was doing Elm, and I think he's got a website and stuff. I can dig up the link and then send it to you. But basically, he was talking about if you have good game development, you can do stuff such as, you have a character that jumps. You don't like how he jumps or she jumps, and you can change the curve, or he falls if you jump because distance and stuff. So the feedback loop of making the game is faster because you just have that and it's no problem. He was kind of talking about Elm and the benefits of using Elm,
Yeah,
and
and
that was the thing.
that's definitely a great thing. But in F sharp, since we don't even have edit and continue, um, I think we're screwed on that. unless
So
unless unless you're pulling all of that data, unless you're pulling all that behavior from a data file that you can refresh in the engine. Um, Unfortunately, because we don't have edit and continue, and maybe this is just me harping on the fact that we need edit and continue, and I'm not really seeing the support from the community that we need to get it done. Um, yeah, unfortunately, that's not going to work in F sharp right now. That type of interactivity, and again, unless all that behavioral stuff is
you
defined
don't
in
have
data.
a Visual Studio not having edit and continue.
F sharp doesn't have it. It does. It's not supported. F sharp's edit and continue is not
Okay,
supported.
I think like in our engine we can edit F sharp on any text file, any text editor, sorry. So we don't really mind that. It's like we don't really need Visual Studio if we don't. So basically, if I could write in, I don't know, Notepad, and that means I can change stuff in real time, I would write in Notepad because
Okay, I think I see.
I wouldn't mind. It's like Visual Studio is great when you're writing a lot of code, but really you need this in very little things. Also, I'm kind of slightly concerned that we're totally derailing the conversation because we're just conversing, and I'm afraid there are people watching or listening, and I wonder if they're bored to death of this. or
No,
not.
I'm not real sure. I'm not real sure of the format of this room. I just kind of like.
Yeah, no, totally. No, I'm just kind of checking with. I kind of take Gerald as the I don't know, room moderator, and I just want to check with him if he's okay with this or where this is going.
Oh no, no, please continue. I'm perfectly fine with the conversation going in whichever direction it needs to. We've been on for what is it? Just over an hour and a half, almost. So, if you feel like you'd like to continue rolling through this conversation, I'm perfectly all right with it.
All right, just checking. I didn't want to thoroughly go off. Sorry, Brian. I just thought it was.
I think we're both kind of unaware. So I think you have a good point, and the point is, okay, so it's not really about Visual Studio. The point is, I think in your case you're doing things a little differently. I think in your case, because you're writing an engine plugin, you're actually able to, because your F# code is done with the plugin, you're actually able to recompile your stuff and then update the plugin while the engine is running.
Yes.
Whereas, because my engine, um, the code I'm talking about is done in like an F#, a pure F# application. I guess what I'd have to do in order to get edit and continue like in practice, like you're talking about, I'd have to set up the engine to. Uh,
Yeah, you can use the compiler services. That's what we're using, and it's great. It was really easy to set up, and one thing that I'm just testing at the moment, and we're not using in production, is you can embed F# Interactive. So you could literally have type code on F# Interactive, and you could just preload references and stuff, and literally play with the game stuff, the code as you go. So far, I've been able to do a hello world, yay! But I spent a whole like 3 hours on that. So if in 3 hours I got something going, I think you can do very, very amazing things.
Okay. Yeah,
so I totally recommend it.
I should not have assumed that Visual Studio or the normal path was the only way to do it. Apparently, if you do a little reflection hackery and compiler services or whatever, a little bit of Uber meta programming, apparently you can do a little better, and you won't need edit and continue to get that type of interactivity in your development process. So that's good food for thought.
Yeah, totally. I mean, have a look. I'm actually fishing up the F# compiler services because it's amazing what you can do. Totally worth it having a look. There's documentation here, and you can use this hosting F# Interactive or hosting the compiler, and you can do stuff like that. You can even have you can compile assemblies and put them there, and that's really handy for production stuff. But maybe when you're on your editor, you can just simply have virtual assemblies. I don't really know what I'm trying to do, so it really depends on your use cases.
Can you also debug, like step debug, place breakpoints on code that you've generated in that way?
Not right now, but at the same time, I can't really show. I'm not really set up with the stuff there. But basically, I don't know if can you see my screen?
Yeah.
Cool. So basically, when I type something and it's wrong, it throws there saying and tells me, hey, you have an error in your thing. This is wrong. So because the scripts that we have are kind of small, like this. There's less than 100 lines of code. You can see where you're going wrong very quickly, and you basically don't need to debug. But again, I'm pretty sure that if you try, you'll find more about it.
Okay, yeah, maybe it's just me being intellectually lazy and just F# to do what the other languages do.
Yeah,
and that's also interesting.
yeah. Well, I really look forward to. I'm gonna make you commit to like a presentation of your game engine, so we can see what you're doing, and maybe by then you'll have the compiler services integrated.
I don't know. I'm pretty lazy.
I always try to. I think you have a lot to say, Brian. So it would be worth it to put you in the spotlight. And I'm smiling here. I'm not trying to be mean or anything. I just wanna. I think it deserves. You just wrote an engine. It deserves to be known. You know. And I think maybe you find stuff like the compiler services. It's like, hey, you could add this, and suddenly you don't have to suffer waiting for a feature that is not there. You suddenly can do something else.
Yeah, if I get the right format for it and it's actually like it actually makes sense, and I'll look at it. So Gerald's gonna buy me a beer, right, Gerald?
Yeah, most certainly.
Okay, good. I'm looking forward to that. Gerald and I are actually very close to one another physically. We just found
Oh,
out.
really? Cool. Well, it's I'd say I'll pass your money to Gerald for after I see your presentation, obviously.
Yeah, and I'm sorry I missed like all of it because I didn't realize that the time format was UTC. So I really don't have really probably any more useful questions.
Well, I think it was very nice talking to you. Finally, I think we talked on Twitter and our places, but it's good to actually put a voice to that Twitter handle.
Okay, sure. Yeah. I'll have to find your Twitter. I guess you are round crisis at Twitter, right?
On Round Crisis I speak mostly about anything else, but as at Silver Spoon is my programming handle.
Okay, cool.
Because the things like I noticed when I was speaking about both things, people were like, "Oh, this is too much of one or the other." So when I split up the when I split up the usages, people were just happy and they were like, "Hey, you're talking too much about this stuff and you're boring." It's like, okay, whatever. So yeah. But anyway, if you want to get in touch or you just want to talk more about game engines, I'm always up for it.
Actually, I wanted to wrap up the broadcast in itself, but I think it's okay to we can keep the Hangout online for now. I'm worried about time constraints for the moment.
Yeah, totally. Go ahead.
Andrea, I'm really grateful that you did this presentation. It's awesome. I'm actually just kind of digging around through the through your example code, and one thing that I noticed, however, not really sure how it's resolved. I did notice that some components are visible in the scene view. I'm wondering if people who are, looking through the downloaded example that you have, if you might be able to help resolve is some of these. You've got icons where they appear to be building bricks. They don't seem to be visible in my case. Is that because you're switching between game view and scene editor, or something else? The scene view in itself doesn't seem to have all of the icons that you had available.
Could they be someday?
Well, I'm looking at the editor, and I'm not sure if it's how it opens the project by default, or if it's maybe a visibility setting. But there's a possibility other people looking through the code may encounter the same type of issue where
Do you think
like.
can help me your screen so I see what you mean because I don't understand?
Certainly, I'll give you a moment. I'll share the screen.
Cool.
Trying to find that icon where it has the share.
Oh, it's on the left-hand side of the Google Plus Hangout kind of window. There's a thing that is called.
Oh, yes, I see it now. Let's see. Okay, you see the screen now?
Nope.
Great.
Gerald, you got a lot of feedback coming out of your end. Is your microphone like faced toward your speaker, or what's going on with
Uh,
that?
I'm not quite certain yet. I may need to turn the mic volume down. One moment.
Actually, the Brian, someone in there on the chat mentioned that Will Smith also was doing the live streaming of Quake, and he's also using container server. So that's someone else you can talk to.
Yeah, I've actually met him in person.
Oh, cool. Yeah, he's a nice guy. Okay, show.
Chill. I don't know if he's really made that much progress since he started working for Takius. I think his time's been pretty full with that. So I'll have to check in on that, see if that's made any progress.
Oops.
And do you see the like the game over, and then let's see, like score meter, I believe had one of those icons on it.
I just see a black screen.
Oh dear.
Yeah, you're not doing it. You may have to restart your Google Hangouts. Sometimes the functionality drops, and you have to restart the app.
Yeah, that might be the
Just
case.
take a screenshot if that's too complicated. Just take a screenshot and put it in here.
Yeah, I can do that.
Whoops.
I have a kind of a practical question while he's setting that up.
All right.
So how did you get all the resources to do all the art for that game?
All the
That,
resources
that
to do
sounds
what? Sorry, all the resources to do what?
okay. If I'm not mistaken, you did the where was it? I was just there. Sorry. You did the Onikira game, right?
Yep.
So, as an indie dev myself, my biggest difficulty is paying for like art resources and stuff like that.
Mhm.
How did you manage that? Like, did you have a budget coming in, or
Oh well. Yeah. It's we're a team of six people, and two of them are artists, and two of them are game designers, and two of us are programmers. So we had some investment, and then we have publishers that help us with that.
that's cool? Maybe you guys should help me out with that because I have a lot of technology and stuff, but I have no practical way to get stuff done other than just through paying for it with my own blood and sweat. And
It's really tough. It's very tough to get funding for anything.
that's pretty much
The things
impossible.
like you, yeah, it really is. Like we've been at it for a while, and the main thing they want is a game. Like there is nothing like an amazing prototype. Like with good art and everything. It's very competitive. And if you want, we can chat offline. But basically, what you need is a good prototype, and not a technical one. You need a game prototype.
Yeah, we'll definitely chat online if whenever this is over.
Yeah. Charles, I'm getting a picture of you, which is very nice. Pictures of your screen. Um, so when okay, let me try to help. If you okay, I'm gonna share my screen. Do you see my screen? Hello. Oh,
Yeah,
hey,
I just see a cat.
can you see this?
I don't see your window.
Oh, you can't see it. Let's see, entire screen share. How about now?
There we go.
Cool. So can you see this yourself?
Yes, I can see that. It's the scene view itself. The tree with all of the game
Oh,
objects in it.
okay. If you turn that off, you can go to view and scene view, and it will open. If you have one, it will kind of keep it there. So say that I take it off, you can do view, scene view, and it turns up somewhere else.
Yes, I'm seeing the scene view. However, when I open up, say, score meter, if I open up that game object, the actual component, the
Oh,
score component F, that's
okay.
not visible for me.
Okay, so what you need to do is you need to build the project. Well, you need to close Duality, build in Visual Studio this thing, build the project plugins, and it should come back. I've seen a bunch of people saying, "No, I built it and it's not there." But then when they build it again, they open Duality again, it is there. If it's not, just try to revert, basically come back to the state you were when you downloaded everything. Before you open it, build the project, and then open it, and it should be there. It's very strange. Some people don't like open it and it's fine, like I have, and some more people have this problem. Does that work for you?
I'm rebuilding right now.
Cool. Just make sure you actually close Duality before you um, before you build, because it could hang on to some resources sometimes. Like actually close it, build, open.
So the solution would be to close Duality, to do a clean and rebuild for the solution, and then open up the editor again. Is that correct?
Yes.
Okay, so if anybody who's watching the stream and having that problem, that would be the way to take care of that.
Yep.
Andrea, I really appreciate this. I'm going to wrap up the broadcast in itself. Your talk is awesome. I'm probably going to be tinkering with this engine myself now. I got myself kind of digging through the libraries now, trying to see what it's capable of doing. So I'm probably going to be fixated on this for a little bit.
That's
Um,
awesome. And also, if you have any questions or anybody watching has any questions, please send them on, because it's good to, generally good things come out of that too. And it's great that other people can use it. I'll update with the new version that has the duality scripting. So,
Awesome. Thanks for the talk. Sorry I came in late.